All right, so you guys said electronegativity is the measure of how strongly an atom can attract an electron. And you guys said that increase that way, increase that way. So based on these trends, the number one most electronegative atom would be what?
It would be based off of those trends. Helium, but helium, neon, and argon can't bond with other elements in chemical reactions. So therefore, it's fluorine.
There you go. If you just follow the trend, these trends, it's like, oh, the most electronegative element is helium. That's not accurate because let's not forget what helium is. It's a noble gas. It doesn't want to attract electrons. It doesn't want to react with other atoms because it is a noble gas. And so that's why when you look at electronegativity charts, okay, that have values associated with electronegativity, they don't include the noble gases. That's why. And so
Great on Chem bond, but it probably takes a bunch of power to get them to bond in the first place.
yeah. So what we need to realize is the most electronegative element on this periodic table is fluorine. Okay, it has a whopping 4.0, which is the highest value for electronegativity on the periodic table. For the Y, you guys associated this with atomic radius, and so going across from left to right in a period, you guys said as you go across a period from left to right, atomic radii decrease, making electrons closer to the nucleus, increasing the attractive force. Remember, when you decrease the amount, if you decrease the distance between the positive and that negative object or entity, you're going to increase the attractive force, okay? Because there actually is a function based on distance. So if you're seeing the atomic radius go down, you're going to actually increase the hold on these outer electrons. And so if you're decreasing the distance between the nucleus and the edge of that atom, any electron from a different atom now has the ability to get even closer to that nucleus. And if other electrons can get close to that nucleus, you got a better chance of attracting that electron. And so what we see here is that smaller atoms are more electronegative for that reason. Okay, for that reason, smaller atoms tend to be more electronegative than larger atoms. And then very similarly to the period trend, the group trend, electronegativity is going to increase as you go up a group, because remember, as you go up a group, you're losing excuse me, you're losing quantum energy levels, you're losing layers, okay, energy shells. And each time you lose an energy shell, your atom is smaller. So that means the distance between your nucleus and your valence electrons is smaller. So you have more of an opportunity to attract electrons from other atoms because they can get closer to your nucleus because you're smaller. All right, electronegativity, phene.